40 times D, 7 inches, minus A revised over 2. So if you want to write something there, you can put A over 2 is A revised over 2. That's 2.62 divided by 2. That's going to give me my area of steel. So I'm going to take 7, and I'm going to subtract from 7 1.31, and I'm going to multiply that by 40. And then I'm going to divide that into 139 to 27.6. 139.95 divided by 227.6. Ooh, got a bigger number than I hoped. Let me run that number through one more time and make sure that I've got it. 7 minus 1.31 times 40. 1.31 times 40 to 27.6. And then I am going to take that and I'm going to divide it into 139.95 to 27.6. 68, that's a good number. Okay, what does this tell me? It's the number of square inches of steel I need for every lineal foot of length. Okay, so how do I do that? So let's look at what it says. There we go. We're at letter L. It says, gives you a little code recommendation. Minimum center to center spacing of the bar is 3T or 18 inches, which is ever smaller. 3T for us is 24. So 18 would govern. And then the minimum spacing should be T. So according to this, we need to space our bars somewhere between 8 and 18 inches on center. So this number right here is going to be between 8 and 18 inches. So let's flip it over. Now this is a new table. You haven't had access to this before. I want you to go to page 449. Not too hard to use, but can be confusing. So go to 449 and you'll see the table. It's table 13.7. And I'm actually going to make a little list. You will not have to do what I'm doing on a test. Okay? I'm going to give you the size. I'm going to tell you what size it is. But this one turned out a little bigger than I'd hoped. So I'm going to pick 3 bars. I'm going to pick a number 4 bar, a number 5 bar, or a number 6 bar. And I need 0.62 square inches per foot. So this is what I need, 0.62 square inches per foot of width. Okay? So here's how you use the table. Put your finger on a number 4 bar. Wander down the table and stop when you hit a number that is 0.62 or bigger. I start out with 0.8, 0.69, 0.6. It looks like I'd have to put those at 3.5 inch centers. I don't want to do that. Let's move down to a number 5. Number 5, go down till you hit 0.62. When I do that, I hit 6 inches on center. And now I'm getting closer. Put your finger on a number 6 bar, go down till you hit 0.62, and I've got 8 inches on center, 0.66. I'm going to use number 7 too. Put your finger on a number 7. Looks like they're going to be at 11 inches on center. I kind of like that. So my assumption was faulty. This assumption was no good. I messed up. Once again, there will be no assumptions required by you on a test. I'm going to give you the bar size, so all you got to do is fill in. So if I was doing this, I would put a number 7, at 11 inches on center. Theoretically, I have to go back and redo part of this because now this 0.5 becomes 0.875. And so theoretically, we're not going to do that today, but theoretically you'd have to do that. On a test, you won't have to worry about that. I'll give it to you. The numbers are going to come out right. You won't have to worry about making that assumption and or correction. Okay, so we've got two parts done. We've got the thickness as 8 inches. We got the main steel as number 7s at 11 inch center to center. So every 11 inches, I'd have a bar running the width of the slab. And now the last part is the temperature steel. I told you that's code mandated. So all we got to do is make sure we meet code. And what does it say code is? If you go to letter O, it says temperature shrinkage steel is, depending on the steel, is going to be either 0.002 or 0.018. Remember that it's a T here, not a D. So for us, letter O, it's going to look like this. Area of steel temperature is equal to 40. 0.002. Width is always 12. Our thickness is 8 inches. So this is going to give me the number of square inches of steel per foot. So I'll multiply it out. Okay, clear. 0.002 times 12 times 8. 0.192. 0.192 square inches per foot of width. Okay, if I decided to use that number 4 there, so I'm going to put my next column over here. Actually, we'll just use 3, 4, and 5 for this one. So let's use a number 3, number 4, or a number 5. And I need 0.192 square inches per foot. So go to the table, same as we did before. Put your finger on 3. Wander down until you hit 0.19. And I hit 19 at 7 inches. So if I use number 3 bars, I have to put them 7 inches apart. Put your finger on number 4, find 0.19. It looks like I've got 12 inches. 0.20, 12 inches on center. And if I decide to use a number 5, 0.19 is all the way down there to 18 inches on center. Okay? Once again, you don't have to worry about it on a test. I would tell you it's a number 4 bar in this case. All you'd have to do is go to the table, look up a number 4, right? That'll be already on the test. All you got to put is the 12 inches in there, and that tells me what the temperature steel needs to be. So what have we done? We took our loading. We factored it. We could change it from pounds per square foot to pounds per foot based on a foot width of slab. We found the moment that it has to resist. We determined the thickness of the slab based on flexure. We compared it to the thickness based on deflection, picked the biggest of the two, got our numbers in order, made sure we had the D's and T's of both scenarios outlined, revised the percentage of steel, took the percentage of steel revised, put into the area of steel equation, took the moment divided by the steel and the moment arm, and got the amount of steel per square inch per lineal foot. Went to the table, decided which bar and which spacing was the best, took care of our longitudinal or main steel, went to the area of steel for the temperature, found the percentage based on steel grade per code, multiplied it, went back to that same table on page 449 and picked the bars that work for the longitude, the shrinkage or temperature steel. So for this particular problem, your answers would be on a test, 8-inch thickness. I would have the 7 on the test, you would put the 11 inches on center. I would have the 4 on the test, you would put the 12 inches on center. And that's basically the same theory we use for the design of beams. Our beam here is too big. So if you go back to what we did before, it should be a mirror image of this based on something that is a little too big. That's the reason why we're doing this right here. This right here takes and makes the steel a little less aggressive because the concrete is taking part of the load and it's too big. So that takes care of chapter 13.5. And 13.5 will be part of the grouping used for test number 3. Our next, after the test,